This video is a review for Unit 11. The way the X game works is, it's a math riddle. We have to come up with two numbers that if we multiply them, we get the top value of 7, and if we add them, we get the bottom value of 8. So those two numbers are 7 and 1. 7 times 1 is equal to 7. 7 plus 1 is equal to 8. Next up, we have to consider factors of 36. So 36 times 1, or 18 times 2, or 12 times 3, or 9 times 4, or even 6 times 6 are all contenders. Which of these add up to negative 13? Sort of these, but we have to make them both negative. And negative 9 multiplied by negative 4 gives us 36. Negative 9 plus 4 gives us negative 13. That's why they work. Possible factors of 28 include 28 times 1, 14 times 2, 7 times 4. That's going to be the answer here, 7 and 4. Because 7 times 4 gives us 28, and 7 plus 4 gives us 11. Factors of 9 include 9 times 1, or 3 times 3. Here it's going to be 3 and 3. Because 3 times 3 gives us 9, and 3 plus 3 gives us 6. Factors of 30 include 30 times 1, or 15 times 2, or 10 times 3, or 6 times 5. It's this last one, but they both have to be negative. And then, negative 6 times negative 5 equals 30, and negative 6 plus negative 5 equals negative 11. Those first 5 are the first skill, the first grade. Each 5 questions is going to be a separate grade here. For this one, it starts off the same. We put 72 on top and 17 on bottom. So right here goes on the top, right here goes on the bottom. We don't bring the X, but we do bring the signs. These are both positive. So factors of 72. 72 times 1, 36 times 2, 24 times 3, 18 times 4, 9 times 8. These are a couple of different options. Which of these add up to 17? These do. So our answer is 9 and 8. But we don't leave it like that. We write this in factored form, which means that our answer looks like this. So if you think about it, we actually did the opposite of the box method. Because if you were to multiply x and 9 and x and 8, you would end up with x squared plus 17x plus 72, which is back where we started. So factoring is like the opposite of the box method. Next up, I'm going to draw an X. I'm going to put 30 on top and negative 13 on bottom. The 30 came from here, the negative 13 came from there. These numbers, it could be things like 30 times 1, or 15 times 2, or 10 times 3, or 6 times 5. It's probably going to be 10 and 3, but they both have to be negative here. How do we write it? In factored form. So x minus 10 times x minus 3. This is these numbers just brought over here. This one, I cannot jump straight to the x method. The x method only works for trinomials that have an a value of 1 and that my exponent is x squared. So there's a problem here. I have to divide out a greatest common factor first. I'm going to divide all 3 terms by 4. If you remember how that works from previous units, none of the x's change here, but each of the numbers are divided by 4. And at this point, I can do the x method with 63 on top and negative 16 on bottom. So this is negative 9 and negative 7. And this becomes x minus 9 times x minus 7. So notice there are 2 steps here. First, I factor out the greatest common factor, which is a 4. I put it over here. Then I factor by the x method, using these values over on the side, and I change that into its factored form. This is the final answer. You have to include the 4. So what's the greatest common factor of these 3? Well, 5 goes into all 3, and in fact we want to get rid of that negative, so why don't we use negative 5? And they all have an x as well, so we can divide by negative 5x each of the terms separately. That means we'll have a negative 5x on the outside of the parentheses. This will be x squared, this will be plus x, and this will be minus 42. If you're not sure how to do this, do the numbers separately. Negative 5 divided by negative 5 is 1. Negative 5 divided by negative 5 is 1. 210 divided by negative 5 is negative 42. And then for the x's, we subtract 1 from the exponent. X to the third becomes x squared becomes x, and this x just goes away. Gets canceled out completely. We're not done. We still have to do the x method. Negative 42 goes on top, 1 goes on bottom. Where did the 1 come from? This invisible 1 in front of the x. My two values here are 7 and negative 6. So I'm going to rewrite this as negative 5x times x plus 7 times x minus 6. So the 7 shows up over here, and the minus 6 shows up over there. And this is my final answer. So notice my two steps. One is I factored out a GCF first, and then 2, I factor with the x method. We did both of these things separately, but now you have to do 2 in the same problem. The last one of this type, we're going to divide all 3 by 3x. This will be x squared minus 6x plus 8. If I do the x method here, 8 on top, negative 6, this will be negative 4 and negative 2. So I'll rewrite that as x minus 4 and x minus 2. So when it says factor completely, this is the step I stop at. And for all the last 3, I had to factor out a GCF first, then use the x method. The first 2, it was just the x method. New problem type for the next 5. These are different because they don't say factor anymore, they say solve. The first thing I want to do is I want to solve for 0. That means everything over here I'm going to move to this side. So I can do it one at a time if I want to. Or I could do it more than one step at a time, but I'm just going to do it one at a time so you can see everything. X squared minus 18x plus 80 is equal to 0. Then I'm going to use the x method. So I'll do the x, 80 goes on top, negative 18 goes on the bottom. Two numbers that multiply to give me 80 are negative 10 and negative 8. And if I add them, I get negative 18. So I can rewrite this as x minus 10 times x minus 8 is equal to 0. But I'm not done. They want me to solve it. So I can't just write the factored form. Instead, I have to figure out what number can I plug in here to make this 0. Well, 10 minus 10 is 0. And 8 minus 8 is 0. So your two possible solutions are 10 or 8. Both of those, when you plug them in for x, will make this equation true. So the right side, I want it to equal 0. Right now it doesn't, so I'm going to add 7 to both sides. This becomes x squared plus 7x plus 12 is equal to 0. At this point, I can do the x method, 12 on top, 7 on bottom. I think 4 and 3 are going to work. X plus 4 times x plus 3 is equal to 0. If I plug in a negative 4 here, that will give me 0. If I plug in a negative 3 here, that will give me 0. Those are my two possible answers. Notice if this was 4, the answer down here is going to be the opposite, negative 4. And if this was a positive 3, the answer is going to be the opposite, a negative 3. Next problem, I want everything on the right to be a 0, so I'm going to cancel these out. We can do minus 2x plus 1, minus 2x plus 1. We're left with x squared plus x minus 20 is equal to 0. I'll do the x method, minus 20 on top, 1 on the bottom. This is going to give me 5 and negative 4. So if I rewrite this, x plus 5 times x minus 4 is equal to 0. What are the values that will make this 0? Negative 5 or positive 4. So when it says solve, you have to keep going to this extra step. Right here is where we factored, but right here is where we solve. So these 5 questions, you have to keep going until you find the actual zeros. This one has a GCF to factor out first. So we'll divide everything by an x, and we get x times x squared plus 2x minus 63 is equal to 0. Then we'll do the x method with what we have left, negative 63 and 2. That's going to give us 9 and negative 7. So we'll rewrite this as x times x plus 9 times x minus 7 is equal to 0. And what can we plug in to create zeros? If we plug in a 0 to the first part, that'll work. If we plug in a -9, it's -9 plus 9, that gives us 0. Or if we plug in a 7, 7 minus 7, that gives us 0. So when they say solve, they want you to keep going past the factored form to identify what the solutions are. What can we plug in for x that will make this true? 0, -9, or 7. The last three, the last section, the last 5, ask you to express each answer in simplest radical form. What we are doing is we're looking for the largest perfect square factors that go into these numbers. So if I think about 18, I can turn this into root 9 times root 2. And I can turn this into 3 root 2. How did I know to look for 9? Well, here's a list of perfect squares. For each of these, we took 2 times itself, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on and so forth. These are called perfect squares. And when we take the square root of these numbers, we get a whole number. So we can split 18 into its component factors, 9 times 2. And we do that so we can simplify the square root of 9 part, comes out as a whole number. And since the square root of 2 comes out as a decimal, we just leave it as is. So what's a perfect square that goes into 8? Well, the largest such possible is 4. So this will turn into root 4 times root 2, which simplifies to 2 root 2. The square root of 4 is a whole number, 2. 45, if I look on that list, 9 is the biggest one that goes into 45. So this simplifies to 3 root 5. For 75, the largest such number on that list is 25. So this simplifies to 5 root 3. 147 is a little bit harder. One method is to just guess and check. So for example, if I take 147 and I start dividing by 4, or divide by 9, or divide by 16, or divide by 25, or divide by 36, or divide by 49, this time you get an answer, 3. So we are trying all the perfect squares until we find one that goes evenly into 147. And this turns into root 49 times root 3, or 7 root 3. Look for a perfect square factor, guess and check with the calculator if you have to. Look for one that comes out as a whole number, like this one.